Hello guys and welcome back to my channel. Today in this video I'm going to check 3 new products. The Skystars KRAMAM, which probably wins the award of the all-in-one flight controller with the weirdest name. A full-cased version of the Foxeer Predator V4 micro FPV camera. And the Eachine TriangleD, a VTX with an onboard DVR. Let's start with the new full-cased version of the Foxeer Predator V4 micro-sized FPV camera. In terms of specs, it features a 1000 TV line CMOS sensor, supports both 4:3 and 16:9 aspect ratios. Its input voltage is between 4.5 to 20 volts. It features a 1.7mm lens, supports both PAL and NTSC picture formats, and you can get it in black or red. Here you can see how it looks next to the Foxeer Micro Predator V4 camera, so as you can see it is well protected. It weighs 6.4 grams, so it's 0.5 grams heavier than the version without the full case, and its dimensions are 19 by 19 by 22.2 millimeters. The version that I have, which as far as I know is the only one which is available at the moment of shooting this video, is the camera which is equipped with an M8 lens, and according to the user manual, a version with an M12 lens should be available as well. Now I've got the camera powered up, so let's quickly go over its settings. On the setup menu, you can set the camera ID, and if you'd like, you can also turn it off. You can adjust the camera picture, set the day and night mode, set the language between the following options, and perform a camera reset. A second configuration menu can be accessed by long pressing the top button on the OSD control board. Over here you can set if you want to display the time and the power on the OSD, set the voltage alarm, perform voltage calibration, set the mode to either day, which is the default option, night, LED, and black and white, switch between PAL and NTSC picture formats, and change between 4:3 and 16:9 aspect ratios. Now since this camera is using a 1.7mm lens, in addition to this review, I might feature it in a side-by-side comparison video, so please let me know down below which cameras you would like me to compare it with. Moving on to the Skystars KRAMAM. This all-in-one whoop-style flight controller features an F4 processor. It came pre-flashed with Betaflight 3.5.6, it supports OSD, has an integrated LC filter, and an onboard current sensor. Its input voltage is between 7.4 to 16.8 volts, and it features a 4-in-1 BLLES 15A ESC. Inside its box, along with the flight controller, you can find some stickers, an XT30 battery connector, 6 cm long 20 gauge battery leads, 4 JST motor connectors, 4 M2 silicone grommets, and the 25 volts 220 microfarad capacitor. The Skystars KRAMAM weighs only 4.9 grams. It features 25.5 by 25.5mm M2 mounts, and its outer dimensions are 33.2 by 32.3 by 3mm. In terms of features, both motor pads and battery plus and ground pads can be found on the top and bottom sides of the flight controller. In addition to soldering the motor wires directly to the motor pads, you can also use these 3 little holes and use these JST motor connectors. The boot button can be found over here. Over here you can find R2 and T2 pads. On the front side you can find ground plus 5 volts and signal pads for using your radio receiver, and in case you would like to use DSM, you'll need to solder these 2 pads together. Next to the battery pads you can find 2 plus 5 volts pads, buzzer plus, buzzer minus pads, 2 grounds, LED, video in, video out, and a TX1 pad. The micro USB connector is located on the bottom of the board at 90 degrees, so you have to keep it in mind to see if it's going to fit the frame that you would like to use. Here you can see how it looks like when the flight controller is mounted on the FlexLC Ninja 3-inch frame, and I highly recommend to use rubber O-rings on the bottom of the board in order to separate it from the bottom plate, as carbon fiber is conductive. Now after carefully soldering the motor wires and the XT30 battery connector, I recommend to use a multimeter and check that we don't have a short circuit. Then using Betaflight, check that all the motors are working, of course with no propellers. After carefully soldering your radio receiver, bind it with your remote controller, and the reason I keep saying carefully is because this is a pretty delicate board and as you can see, all the soldering pads are pretty close to each other. Now in order to configure the ready receiver, we need to head over to Betaflight, and by the way, even though the serial RX is going to be enabled by default on UART 1, if you are going to use the SBus pad on the front of the flight controller, you need to enable it on UART 2. Now we need to make sure that SBus is selected under the receiver tab, of course, in case you're going to use an SBus receiver. And now we can head over to the receiver tab, connect a battery to the quadcopter, and as you can see, everything works properly. In case you're seeing weird icons on the screen when the OSD is activated, it means that you need to upload new phones. So you have to head over to the font manager under the OSD tab on Betaflight. Then plug a battery to your quadcopter, of course without the propellers on, and press the upload font button. It's going to take about 20 seconds, and after that the new font is going to be flashed to your OSD. Now basically, in order to complete the build, we need to add an FPV camera and a VTX, which is of course going to be the Eachine TriangleD. The VTX got its name due to its shape and the fact that it features an onboard DVR. In addition, it is designed to be mounted on top of Whoop-style flat controllers. It supports 40 channels. According to its specs, it supports both smart audio and TRAM protocols. It has a selectable output strength of 25, 100, 200 and 400 mV. Its input voltage is 5 volts, and its 720p onboard DVR creates a new file every 10 minutes. The weight of this Whoop-friendly VTX is 3.5 grams, and its dimensions are 40.6 by 26 by 6.3 millimeters. In terms of packaging, inside the box along with the VTX, you can find the user manual, a simple linear antenna with an IPX connector, these harnesses that are going to enable you to connect the VTX with the camera and the flight controller, and a bag that contains some screws, spacers, and silicone grommets. Connecting a camera to the VTX is done using this 3-pins connector, and connecting the VTX to the flight controller is done using this 5-pins connector. The video in is going to be connected to the video out on the flight controller, the camera out to the video in pad, smart audio pad to a free TX UART port, and the plus 5 volt and the ground pads are going to be connected to the plus 5 volt and ground pads on your flight controller. Controlling the DVR function is done using this button. You need to short press it in order to start the recording and short press it again in order to stop it. The DVR supports up to 32GB micro SD cards, and you should note that in case you are not going to stop the DVR recording, your file is not going to be saved. Setting up the channel, band and output strength is done either using smart audio or using this button over here, and you can refer to the user manual in order to see how it's done. Now by the way, even though it states under features that the VTX is compatible with both smart audio and TRAM protocol, I can confirm after testing it out that the VTX is only compatible with smart audio protocol. Now let's measure the output strength of the VTX. When it's set to 25 mV, I'm getting about 40 mV. After a minute it's down to 25 mV, and its temperature at its hottest point is about 60 degrees Celsius. When the VTX is set to 100 mV, I'm getting about 90 mV. When it's set to 200 mV, I'm getting about 250 mV. And when it's set to 400 mV, I'm getting about 350 mV. I didn't leave it on the bench for a minute when it was set to 100, 200 and 400 mV because the temperature of the VTX gets really high, and I was just afraid I'm going to burn it without being able to test the VTX. Anyway, just like any other VTX, make sure that it gets enough ventilation, always make sure that the antenna is properly connected, and never leave it turned on the bench for too long. You might have noticed that when testing the output strength of the VTX, I used a different flight controller in order to set it up, and that's because I had issues configuring the VTX via smart audio using the Skystars KRAMAM when it was flashed with Betaflight 4.1.1. After reflashing it with Betaflight 4.06, everything works fine, and I advise to use this version in case you're experiencing any issues. As you can see, now the quadcopter is fully assembled. It weighs 89.2 grams, and including a GNB 520 mAh 3S LHV battery, which is the battery that I recommend to use with this type of builds, it brings us to a total weight of 131.1 grams. Now before showing you the flight footage, since I've already tested this quadcopter, I'm going to give you my feedback regarding all the items that I've tested. As expected, the Foxeer Predator V4 micro FPV camera performed great, However, out of the box, the camera was out of focus, so I had to adjust its lens, and I recommend that before installing the camera on your drone, make sure that the camera is focused. As for the VTX, as you're about to see in the flight footage, it's performed well, even when using the simple linear antenna. However, no matter how many SD cards I've tried, I just couldn't get the DVR to work, and I did try many different kinds, and I also formatted it using different computers, and I think that my unit is just faulty. So keep in mind that if you are going to get this VTX, it might happen to you as well. Finally, as for the Skystars KRAMAM all-in-one flight controller, unfortunately, even though its price is very appealing, I can't fully recommend it, since when flying the Ninja 3, it suffered from some weird twitches, which I suspect were caused by ESC desync issues that eventually led me to crash the quadcopter. Maybe for a 1S or a 2S brushless whoop, it's going to be fine, but if you're going to build a 3-inch quadcopter with more demanding motors such as this one, probably it's best to get a more reliable board. I'm going to wrap up this video with some flight footage of my newly built Flexo C Ninja 3-inch quadcopter, and of course, if you have any questions about any of the parts that I used, feel free to ask them in the comments section down below. As always, I would like to thank you for watching my video. I hope you enjoyed it and you find it useful, and if you did, don't forget to leave a thumbs up and consider subscribing to my channel and hitting the notifications bell if you're not already subscribed. See you on my next videos, and goodbye.